Hi, this is Section P.6, which is on factoring. So the first example says factor out the common factor. So you want to look through all the terms and see what is a common factor. Well, between 4, 6, and 7, there is no common factor. So now we move on to the x's. X squared, x, x. X would be our common factor. So I'm calling it the GCF. It's going to be x so far. And then y squared, and y. They all share a y, so xy would be our GCF. So the way you factor out the GCF is you're really dividing by the GCF. So divide by xy, divide by xy, divide by xy. And that's how you get the GCF. All right, so now you're going to be left with, here you're going to be left with x squared divided by x. You subtract the exponent, so that's 2 take away 1 is 1. So you got 4x, 1, and then the y's cancel out completely. Minus the next term, you have 6, and then the x's cancel out completely. And then you have 2 take away 1, which is 1. So it's just going to be 6y to the 1. And then the final one is going to be plus 7. The x's cancel out, the y's cancel out. So that is all. So our final answer is just xy, parentheses 4xy minus 6y plus 7. That is the final answer. When you have trinomials like this, you have to do what's called, I call the diamond method. So on the diamond method, you need to have a times c as the top number. And on the bottom is b. So a is the leading coefficient, which is 3. b is a linear coefficient, which is negative 16. And c is a constant, which is 5. All right, so now we know what to place up here. It's a times c, which is 3 times 5, 15. So that's going to go here, 15. And b is negative 16. So now you have to think of a combination of two numbers whose product is 15 and whose sum is negative 16. Well, there's only one combination, and that's going to be negative 1 times negative 15. If you multiply these, you get the top. If you add these, you get the bottom. All right, then you look at the middle variable. It's x. So you place an x here and an x here. And then you have to write out the 4 terms. The first term is going to be 3x squared. That doesn't change. Instead of writing the middle term as negative 16x, you're going to write these 2 terms out because they add up to the middle term. So you're just breaking up the middle term into 2 different terms. And it doesn't matter which one you put first. I'm going to put the 15 first, but it doesn't really matter. Followed by the negative 1x, followed by the 5, which is the last term. So there should always be 4 terms, the first and the last. The middle term gets broken up into these 2 terms. Then you do what's called factoring by grouping. You group the first 2 terms and you take out the GCF. The GCF is 3x. So if you take out the 3x, you're going to be left with, well, you're dividing out the 3x. You're going to be left with x minus 5. All right, and then you do the same thing over here. You take out the GCF. There's nothing common between these 2 terms, but whenever this is negative, you always want to factor out a negative. So we're going to factor out a negative, which means we have to divide by negative 1. And then we are left with, well, we factored out a negative 1, basically, right? So that's what we're doing here. We're taking out a negative 1, which is there. And if you divide by negative 1, you're left with positive x minus 5. And these 2 binomials should always be the same. If they're not the same, then that means we did something wrong. All right, the final step is to take out the new GCF, which is a common factor, x minus 5. And you're left with 3x minus 1. And that is our final answer. So it's kind of a process. You'd create your diamond, you identify your A, B, and C. A times C goes on the top, B goes on the bottom. You find the combination of the two numbers whose product is the top and whose sum is the bottom. You look at the middle variable, that's the variable that gets placed there. Then you write out the four terms, 1, 2, 3, 4. And then you do the factoring by grouping, take out the GCF, factor out by grouping over here. The GCF was -1. And then you take out the final GCF, which was x minus 5. And you're left with 3x minus 1. So that's the process. Let's try another example. Well, this one is called the difference of two squares. So the way the difference of two squares works is you have a squared minus b squared, and that can be written as a plus b, a minus b. And you can verify that by foiling. If you foil, you're going to get this expression back. So here you notice that this is a perfect square and this is a perfect square. So you can rewrite that as 7 to the second power, because that's 49, minus 4z to the second power, because that's 16z squared. So that is that, and that is that. So now you can apply the formula, a plus b, a minus b. This is your a, this is your b. So we got a plus b times a minus b. That is our final answer. All right, let's move on. Factor the perfect square. So whenever you got a perfect square trinomial, you can tell it's a perfect square because the first term is a perfect square and the second term is a perfect square. So you can write this like this. You just write two sets of parentheses. You factor that, and you factor the last term. The first term would be 8t times 8t, 8t times 8t. The last term would be 2 times 2, 2 times 2. However, you need the middle term to be -36. That means the inner, outer must add up to -36. The only way that can happen is if these are negatives. So let's place negatives. And let's check our answer. Inner, -16t. Outer, -16t. If you combine those, you get negative. Oh, wait, this is off. Something is off here. Oh, I see what I did wrong. That's 9t. My bad. Sorry about that. That's a 9t, not an 8t. Oops. So that was my mistake. Let's do that one more time. So now we have 9t, 9t, inner, outer. So now it's going to be, that is what, 18t, and 18t is -36t, which checks out. So that was just the checking process. So it checked out. So this was indeed the correct answer. You can also write it as a perfect square binomial, 9t minus 2 to the second power. So there you go. That's how you factor perfect square trinomials. You first check to see if the first term is a perfect square, which it was. The last term is a perfect square, which it was. And then you have to check to make sure that the inner and outer terms add up to the middle term, which they did. All right, the last page says factor the expression by grouping. We've already done grouping examples, so let's do it again. So first thing you got to do is group the first two terms and take out the GCF. The GCF is x squared. That's what they both have in common. So x squared comes out. If you divide it out, you're going to be left with x plus 5. All right, now you look at the next pair of terms. There is no GCF. So when there's no GCF, then you just say plus 1, because you're really dividing by 1. You're not changing it. So The reason why is because you need some kind of placeholder. You need something in this place. So 1 does not affect the expression, so that's why I'm putting a +1 there. And if you divide by 1, it doesn't change it. It just remains the same. And you always want to check that the binomials are the same, which they are, which means we're doing it correctly. You factor out that GCF, which means divide it. And now you're left with x squared plus 1, and that is our final answer. All right, this is the last problem. Factor the expression completely. So we have to do a diamond again, like we did the first example, or the second example, I think it was. So remember, it's A times C and B. A is 6, B is -5, C is -6. Coefficient, constant. A times C is -36. And then we got B is -5. So now we have to think of a combination of numbers whose product is -36 and whose sum is -5. I'm getting -9 and +4. If you multiply, you get the top. If you add, you get the bottom. You look at the variable in the middle, that's an x, so you have to place an x next to these two numbers. And then you write out the 4 terms. The first term is 6x squared. Second term is -9x. Third term is +4x. And the last term is -6. Then we do the grouping method. You group the first 2 terms. The GCF is 3x. Divide it out, divide out. We're left with 2x minus 3. Then you take out the GCF from the second group of numbers. The GCF here would be +2. So +2, divide out the 2's, parentheses, 2x minus 3. Check to see if the binomials are the same. They are. Factor out that binomial, 2x minus 3, divide it out, and you are left with 3x plus 2, and that is our final answer. And that completes this section.